Hi, in this session, I'll explain how to create custom classifier for text dataset in natural language processing. First and foremost, I'll create a data which is custom dataset. Then I'll perform logistic regression of this dataset. Then I'll move to naive-Bayes theorem. Then I'll illustrate linear support vector machine and will check accuracy of each algorithm. Let's see how it's going to perform one by one. What kind of operation we can go ahead with this text dataset also. First and foremost, I need to import basic libraries over the given cell. So I'm going to import basic libraries. So these are all the libraries: scikit-learn, linear model, logistic regression, accuracy score I'll be using for this algorithm. Then I'll be creating a custom data set which I'm having already created. So here you can see my data set is there and I'm going to create this data set. So first and foremost, I'm going to create this data frame. This would be data frame and this would be column names. Here you can see this is my column data set. First column is called text, second column is sentiment. So I'm having all this stuff and there are 20 rows in my data set. I'm having 20 records out of this. Let's see how I can perform this data set over the given column. This is data frame which I created here. Now I'm going to create some kind of sampling. So I'm going to create this sample fraction. So let's say I'm going to run this code, and what will happen? Let's run this previous cell. Now you can see this is not showing any error. What happened here? Here I am just creating a sample data set. This would be a sample option. Okay, so this would be a sample data set and this would be a index. So I'm going to drop this index, and fraction 1 is equal to means you are taking 100% of the data but in randomized order. The fraction parameter in sample determines the fraction of rows to return when fraction is 1. It means shuffle all the data without dropping any rows. Okay, wherever index drop is equal to true, resets index after shuffling and removes old index drop true, ensure old index is not added in a new column. Okay, there is another part. What is the another part? For example, let's check this data dot shape. What is the data dot shape? This is having 20 rows and 2 columns. What will happen if I create another column? With this column I'm going to create data is equal to and fraction is equal to 2. So what will happen in this scenario? We will have 200% data set and replace is equal to true. What is the replace is equal to true? Because I'm going to take randomly sample twice the number of rows from data. If you won't include this replace is equal to true, an error will occur. This error occurs because when fraction is equal to 1, pandas require replace is equal to true to allow duplicate sampling. Without it, pandas cannot sample more rows than existing in dataset. Okay, so let's run this cell and let's check my data set again. Can you see now this 40 cross 2 means I am having double data set. Now I'm going to keep this only 100%, not 200%. I'm going to make it comment and then checking the shape of this data set. Can you see now again I'm having 20 rows and 2 columns. Okay, now why we are doing this one? Why we are shuffling this data set? Because it is useful in machine learning when you need to randomize data before splitting into training and testing sets. Let me know if you need further classification. I'll include all the documents in the description box and in my GitHub account as well. Now here you can see this is showing the text and this is showing the sentiment value. So whatever the text is there, this is divided into positive and negative sentiment, and I need to vectorize this data into different forms. Okay, so I'm going to divide this data into X and Y. So X will contain my text data set and Y will contain my sentiment. Okay, now I need to split into, first I'm going to perform this text into vectorized form. So I'm going to perform counter vector object. So this is the counter vector, and then counter vector dot fit transform. I'm going to transform this data set. Okay, this is going to convert my vectorized format. Then I'm going to convert into array and getting the feature name. Let's move it up, then moving here. Okay, can you see now it is converted into counter frame. Now let's see, can I see bag of words? Yes, the final output is defined inside the bag of words. Can you see this is all having 0 and 1, and the feature names are giving at the top, all the relevant words are there, and we have converted into vector, which means we have 0 and 1 means we have converted into integer numbers, which is very useful for machine learning, because machine cannot process words, characters, punctuations and everything. Before moving towards logistic regression, I'll have to convert into X train and Y train, and I'll have to divide my bag of words into test size. This test size means 30% for testing, 70% is for training, and randomized state means I'm going to keep it same. Let's divide this data set. Okay, let's check the value, the size of X train dot shape. Can you see this is having 14 rows and 118 columns. If you will check the other values, for example, I'm going to check Y train, so we will have the next value. So this is having again 14 cross this one, only one row is present there. When you do not have any other range, so this is showing only one row, means we have only a single data set here. Okay, now we have 14 rows and 14 rows here. Okay, let's move to the logistic regression. Here I am going to deploy a logistic regression object over my X train and Y train. I'm going to fit this value. So let's create this LR object and going to predict over my X test. So once I will predict over the X test, this will give. Let's see the X text value. So if you want to check this X text value, so you just go back here, just replace this value from train to test. Can you see this is showing 6? So 6 means when you go here, which means 14 plus 6 equals to 20, which means we have total 20 rows. Yes, that is absolutely true. We will have to convert everything into X train and Y train, and this data set will be defined into certain numbers. Okay, let's move ahead. Once we have predicted this data set over the X test, let's check the accuracy of this data set. I'm going to check the accuracy of this part. I'm going to see this is showing 33%. Yes, it is very low, it is very novice data set, no issues, we can move ahead. If we will increase more data set, and we will have more partition and more other parameters defined, then you can leverage out of the box functionality of this logistic regression. Let's run this one. Can you see this is showing 1 2 3 4 5 6 output for my Y value, but what is the exact value, current value? And here you can see this is the value. Okay, this first value is matching. Yes, this is also matching. This value is not matching. Yes, this is not matching. This is mismatched. This is again matching. Yes, this one is matching. This one is matching. Yes, this one is not matching. This one is matching. Yes, this one is not matching. Here we have positive, where we have positive, means out of these 6 only 2 are matching, rest are not matching. This is the reason this is showing only 33% data with accuracy. No issues, we can increase this data set by making more values. Now I'm going to perform the report, classification report over the precision, recall and F1 score. You can go ahead the support vector and negative and positive two classes. Then this is again showing very low accuracy. So main points we have covered regarding the classification and the report of these two binary numbers. We are not bothered about the accuracy as of now. But let's see how Bayes theorem is going to perform. I'm going to first import my libraries, scikit-learn, going to import multinomial Bayes theorem. So this would be objective for my X train and Y train, and over the objective, once I have trained and tested, then I'll predict it for my X text. The procedure is same as the logistic regression we have done earlier, and then I'm going to perform this value over the next value. Can you see this Y prediction is having 66%? Okay, now which means this is the 66%, like better than logistic regression. Okay, let's see the classification again. Here you can see classification is again showing much better report. So you can discuss any question, any query regarding this classification report as well. Okay, let's see how linear support vector machine is working. First and foremost, I'm going to import basic libraries, scikit-learn from this logistic regression and SGD classifier. So these two libraries and these two terms are very much essential for your pre-processing. Let's define support vector machine SVM with this SGD classifier and fit over X train and Y train. I'm going to train my parameters. Then I'm going to test the same, going to predict this value, and let's see the accuracy in support vector machine. Can you see this is showing 33%? Not worry, do not worry, because you can increase this parameter again, accuracy in upcoming sessions. Okay, so in this unanswered question, how you can check the accuracy, you can increase the accuracy, there are several parameters involved. So as of now, we are just deploying all these machine learning algorithm over text data. So what we have done, so here you can see this classification report of SBM, but what we have done earlier, we have done pre-processing part of my text data. We have converted this text data into BERT so that we can process further for different custom classifier. This was all about the combined custom classification. Thank you so much.